Think of the worst thunderstorm that you've ever been caught in the UK. Maybe you got soaked through, maybe some trees got blown over, but at least it only happens once or twice a year, right? Thunderstorms can happen much more often in the tropics. For example, in the Sahel region of West Africa, massive thunderstorms are a regular occurrence in summer. They can last for several days, they're roughly the size of England as a minimum, and these huge storms have a huge impact. They're the cause of around 90% of rainfall in the region. Great for bringing some moisture to an area that's usually pretty dry most of the year, not so great for causing severe flooding, which displaces thousands of people. Even less great, the most intense storms that cause this flooding have tripled over the last 30 years, and it's looking like they could increase even more. Well, we think. Maybe. The thing is, it's actually pretty difficult to estimate how many thunderstorms are going to happen in future because thunderstorms on the scale of continents are pretty small. If you have a global climate model, a computer simulation of the whole world's atmosphere, which we use to predict how climate change might affect weather in the future, predicting every tiny thunderstorm is a little bit impractical. But when these storms are big, like the ones in the Sahel, they start to matter because in order to sustain themselves, those storms actually cause motions in the atmosphere on a larger scale, and we need to account for this when predicting larger weather features. But it's tricky when these storms are too small to show properly. It's like when your internet's running really slow when you're on a Zoom call, and everyone turns into like vaguely people shaped blobs. There are still people on the score, but it's pixelated. You can't see their expressions, gestures, or the carefully created bookshelf behind them. Our global models can produce big thunderstorms, and clever techniques mean we can approximate how they impact the area around them, but we're not really getting the whole picture. That's where my research comes in. For the first time now, we have regional simulations with a high enough resolution to represent some of the processes that directly cause storms. Before, we've had small modules of individual storms, but now we can see how thunderstorms interact with larger motions, especially in the tropics. This can tell us which features are really important to get right in global models, so that if we do have to pixelate our storms a bit, we know how to do that while keeping the information that matters for getting things right on a large scale. So, what are these important details? Well, we're still finding out. But one example is that some of these storms are part of bigger systems, African easterly waves. Atmospheric disturbances, which often cause thunderstorms, but also are intensified by thunderstorms. These waves can move off the coast of Africa into the Atlantic, and often turn into tropical depressions, which end up being hurricanes that hit the US. And if that's not enough, well, these hurricanes can also travel north as they dissipate and back across the Atlantic to the UK. So, in order to predict the storm you imagined at the start of this talk, sometimes you need to know how thunderstorms in West Africa work as well.